Today we're going to start on lesson 3.3. I'm calling it a functions library, really just kind of reviewing the basic parent functions and then talking about piecewise. Our basic parent for a square root function is this guy right here, forming your basic parabola. The intercept here would just be at the origin 0, 0. This would be considered even because it is symmetric to the y-axis here. The domain would be negative infinity to positive infinity, and the range would be from 0 to infinity. Your basic cube root function looks like this here. Again, its intercept is at 0, 0. This is considered an odd function because it is symmetric to the origin, up 1, over 1, over 1, up 1. The domain is negative infinity to positive infinity, as is the range as well. 1 over x is our basic rational equation, and this guy is going to look something like this, hugging along the axes with asymptotes here and here. This one does not have any intercepts, neither x or y. It is considered an odd function, also symmetric to the origin. Your domain would be negative infinity to 0, picking up on the other side of 0 to infinity. And the same would hold true as well for the range, because the asymptotes are sitting on the two axes. Okay, looking at your basic square root function, starting at 0, 1, be looking just about like that. Its intercepts are both 0, 0 again. It's neither odd or even. It's not symmetric to the y-axis or the origin. Our domain does include 0 and goes to infinity, and the same is true for the range. Your basic cube root function then looks something like that. Again, its intercepts are at 0, 0. This is considered an odd function. It is symmetric to the origin. Our domain is negative infinity to infinity, and same is holding true for the range. The last one we have is our absolute value function, making a nice V like that. Its intercepts are 0, 0. This guy is considered even. It is symmetric to the y-axis. Domain is negative infinity to positive infinity, and our range is 0 to infinity. And the reason we're reviewing all these is that we can use them when we're doing our piecewise functions. So let's take a look at our piecewise. So basically a piecewise function is a function that's defined differently depending on the domain. So if I'm looking at my example here, for a domain of x is less than or equal to 2, we're going to follow this rule over here. And when it's greater than 2, we're then going to follow this rule here. What I like to have students do is just kind of put up a boundary line so I know we have something happening at 2. Again, it's dotted, it's not really part of the graph. I'm going to go ahead and graph this function. So we're looking at a y-intercept of 2, and then it has a slope of negative 1/2. So we're going to go down 1 over 2, which will land us right here on this boundary line. I do say it says or equal to, so it's going to be a solid dot, and just kind of go in this way. So I know this piece is going to go like that. Then I need to graph what's happening here, the square root of x minus 1. Where students make mistakes is they want to start on the boundary line, and we can't. We still need to start on the y-intercept here. So we're going to go, starting normally would be here, and then let's just kind of see what happens. If you had 1, you would be at 0. If I was at, let's pick a good number here. Let's say we're at 2. The square root of 2 minus 1 is going to put us about kind of like here. Then let's pick up a good number. The square root of 4 minus 1 would get us to be square root of 4, 2 minus 1. That would put us right at 1 there. And this guy's going to be looking something like that. Okay, let's take our notes over to the other side and try that again. So again, I have some things happening. Between -4 and 2, we have the function happening here. At 2, it's going to equal 1, and then at x, where we're greater than 2. So I'm looking at 1, 2, 3, 4. At -4, something's happening. Something's also happening at 2. Okay, so then I go to my graph here and I say between -4 and 2, I'm going to use this rule. So we're going to start at +2. The slope is 1/2, so we're going to go up 1 over 2. I see that we don't have the or equals to, so we're going to have an open circle there. And then I'm just going to graph the rest. See here, this is also an open circle right here, and connecting those two there. Then it's saying at 2, the function's going to be 1. So I have just a single dot right there. And then when it's greater than 2, we're picking up x squared minus 1. So normally we would start here, we would go up here, and then we would go up 1, 2, 3 to pick up again. Just to get ourselves, we're going to start here. If I put 3 in here, we're going to get 8, which would be up here somewhere, and then the graph's going to kind of take off and go in that direction. We can evaluate these guys. If I want to know what is f of -1, I would go ahead, put -1 in here, because that's where the domain is valid, and we would get 1.5. If I want to know what is f of 2, now that's what the domain is here, we would say 1, and f of 3 would get us 8. Our domain here is going to be not including -4 going all the way to infinity. And for our range, we're going to be 0 to 3 and picking up from 3 to infinity. Soft bracket on the 0 because of this open circle. We cannot include the range of 3 here because it is open, and that's our range there. Let's take a look at example 3. Okay, so now we're looking at the absolute value of x plus 2 going between -6 and 0. And then we have something else happening at 4 and another graph happening at 6. Okay, so if I'm thinking about the absolute value plus 2, this plus 2 is going to move my graph 2 units to the left. So I'm going to start here. And then it's just your basic absolute value graph. I am noticing the or equal to, so we have a nice solid dot there. And continuing the rest of the absolute value. Then between 0 and 4, we're looking at the square root of x. It's an open circle here, be 1, and then at 4 we would be at 2. This is a nice closed circle over there, looking something like that. And then between 4 and 6, we're at -2x plus 5. Now remember, we do need to start 4, 5, on the y-intercept. So going down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. This is where I'm going to pick up. It is an open circle, and then down 2 over 1, and we would continue in that direction. If I'm looking at what is f of -3, I would be evaluating over here, so I'd get 1. F of 0 would be, let's see here, if I'm just looking for f of 0, I'm going to include this over here, so it would be 2, because this is where the or equals to. And then find f of 3, I'd be in this range over here, so that would be the square root of 3. Looking at our domains, we are starting at -6 and including it, and heading all the way to an, this was not an arrow over here, heading to an open circle over here, so 6 like that. Our range, on the other hand, let's see here, we are starting at, that would be 1, 2, 3, 4, 5, 6. We are starting at -6, heading to -3, and then picking up at 0, but including 0 because of this point right here, and heading all the way up to 4, and that would be included as well. Okay, let's move on to example 5. Now we're just going to go backwards. You need to write the piecewise function. You could call it g of x according to the instructions here. So just kind of, I like to go in pieces, just kind of moving left to right. If I need to get the equation of this graph, I can see it has a slope of -2. It's going down 2 over 1. If I were to continue that pattern, I would actually get the y-intercept. So down 2 over 1, down 2 over 1. So the actual y-intercept is -7. So this is going to be -2x minus 7. And that's going to be in between the domain of -5, and that goes all the way to -2, and including -2 there. The next piece is between -2 and 1. Since I have a closed bracket here, I'm going to leave it open here. It could be closed on both, or just one or the other. So the domain there is then it's going to have a soft bracket over there. That's just the function -3. And then I'm looking here. Normally my square root function would start here, but it moved 2 to the right, so it's going to be x minus 2 squared. I also noticed that it moved down 1, and that domain's going to be between 1 including and 4 including. And that concludes our lesson on piecewise.